This is section 7.03 of the Unit 7 Notes, Geometric Models. Today I am, as in you are the student, discussing patterns and scale factor so that I can identify and describe geometric transformations, reductions, and enlargements. I will know I have when I can successfully identify and describe transformations and calculate scale factor. The specific TEKs we're looking at for today's lesson is 6A, 6B, 7D, and 7B. Exploring transformations. I have a website that I would like for y'all to go to. It's linked right there in the notes. If you have access to the ClassKick notes, just simply log in and then click on the link that's right on page 17. Or you can type it out from what you see right there on step 1. Go to geogebra.org and then enter the rest. Select each option to view the different transformations and then describe what happened to the figure when you selected rotation, reflection, enlargement, and translation. So when you go to this website, this is what it will look like. I'll zoom in a little bit so y'all can see. So you have 4 different things: rotation, reflection, enlargement, and translation. And as you can see, right at the bottom, there is a slider that you can mess with to do the specific thing it has for each section. So for rotation, you can move the object around. You can move this object. And then you have a center of rotation that you can move. And then once you're happy with where everything is located, you can use this slider right here at the bottom to have that image rotate around that center. Okay, so you can mess around with that however you want. And then just put your answer over here in ClassKick for rotation. Reflection, you have a few sliders. You have this line right here that you can move all the way around. You have a slider right here for the angle of this line. And then this object is the reflection across that line. So again, just mess with that, then put your answer in ClassKick. Enlargement has the object and then the image, either above it or below. As you can see, this has a smaller image of the object. You can move the center wherever you want. You can move the object. And then you can alter the scale factor here, either decreasing its size or enlarging the size. And then again, moving the object to see what it does for enlargement. Then the last one, translation. You have the object, you have the image. You can move the image by the horizontal slider or the vertical slider to mess around with translation. Oh, and you can click on the arrows or the points right there to change the shape of the object and then mess around with the sliders too if you would like. And again, go through each one of these and then type down what you see going on with each of these different things. Okay, I'm going to move on to the next part. So we're going to talk about a few different translations for this lesson, or transformations. We're going to look at translation, rotation, reflection, and then glide reflection. Okay, so you can see these static images, and translation just moves one image to a different location. Rotation takes the image and then just rotates it around a center point. Reflection takes the image and then reflects it across a particular line, a line of reflection. And then glide reflection takes translation and reflection, puts them together and then transforms the image over and, well, across and over a particular line. Okay, on this next page, I have some GIFs, GIFs, whatever you want to call them, of what it is I'm describing. Translation, as you can see, just moves one side, the image from one side to the other. Rotation takes it around a particular point, in this case the origin. Reflection just takes the image and then moves it over a line, reflecting it. So easiest way to think about reflection is hold your hands in prayer and then fold them out. That's exactly what's happening with reflection. And then glide reflection. The easiest way I could describe it is like you're walking. You take the footprint, move it up, and then flip, up and flip, up and flip, up and flip. Okay, so study those transformations for a little bit, and then I have a you try that I would like for y'all to attempt. So match each type of transformation word with each picture. You have 8 different pictures, and you have 8 words to match. Okay, there's 2 of each. So take one of these words, click and drag to what you think the image that it best represents, and then do that with all 8. Do the best you can. So pause this video, try this problem on your own. If you need to check to see if you did everything correctly, you can move these boxes and check your work. Otherwise, I'm going to continue on and show y'all what the answers are. Okay, for number 1, that is a translation. All we see is the image move from one side to the other. Number 2, glide reflection. We have a foot that goes over, reflects, over, reflects, footsteps. For number 3, we have a reflection. You can see that the image of the volcano or mountain is reflected on the river, lake, whatever that is. Probably a lake. Number 4 is rotation. It takes the original heart image and then just rotates it 90 degrees to the right. And that's it. Number 5, we have a reflection going on. You can see the image of the swan is reflected across to the right and down as well. So this is a reflection. Number 6, that picture of 6 fighter jets or 6 jets. They're probably not fighters. I have no clue. This is translation. It just takes the original image and then moves it around a few different times. Number 7, I'm not sure what this is called. Maybe it's an ampersand. I have no clue. But this sign right here, this musical sign, gets rotated from the original spot to its new location. And then the last one, number 8, is a glide reflection. You can see the leaf, it moves over and then reflects, moves over and then reflects, moves over, reflects, and so on and so forth. That's it for you try number 1. Next, patterns. A pattern is a repeated design. What pattern can you spot in each picture? So the bottom right, you can see triangles being represented in a red, blue, red, blue, red, blue pattern. You can see, I believe that's octagon and an oval. Octagon, oval, octagon, oval. You can also see a light blue, yellow, light blue, yellow pattern. And then you can see the star, hearts, yellow, pink, etc. And then the arrows, up, down, and so on and so forth. You can see a pattern with the pencils, different colors, different sizes. You can also see a pattern with these squares, cubes, different colors through the horizontal, through a diagonal. So there's different ways you can spot a pattern with a lot of these images. Strip pattern. A strip pattern is a horizontal pattern that continues indefinitely in both directions. So to the left and to the right, that pattern will continue on forever. All strip patterns map back onto themselves after a transformation. So if I take a part of that pattern and move it around through some type of transformation, through a reflection, through a translation, through a rotation, glide reflection, etc., they all map back to the original somehow. So the pattern goes back to the original. So in this example, we have a pattern. We have what looks like ice cream cones being repeated over and over and over again. So this is a strip pattern. Identify where the pattern begins to repeat. As we can see, after about 2 of these, we can see it repeats. Every 2, the pattern starts to repeat. So now we want to know what type of transformations are going on with the pattern from step 1. So one of the things that we can say is that we got a horizontal translation. We take this image right here and move it from left to right. Move it again and again and again and again. So we have a horizontal translation going on. It's a slide from left to the right. Okay, we also have others, like a rotation. So is there other transformations that maps the pattern onto itself? Yes, we have a rotation going on. So if you take this image, or you take the 2, and you rotate it 180 degrees, it'll go back to the original pattern as well. You could also just take one of them and then rotate it indefinitely to create the strip pattern. So when describing strip patterns, which is going to be some of the problems you're going to see on y'all's quiz, you need to first identify where the pattern starts to repeat. And then from there, see if you can take one of the 4 things: reflection, rotation, translation, glide reflection, and see what pattern or what transformations you can get from those strip patterns. Each strip pattern has one of those in it that when you perform the transformation will make it go back to the original somehow. We need to figure out what that is with each of these strip patterns. So here's another example. We have an A and a Y being repeated all the way through. Okay, identify where the pattern begins to repeat. Begins to repeat after the first 2 letters, right here. So we got A, Y, A, Y, A, Y, and so on and so forth. So now, after we identify, is there one pattern that we can see immediately from where it begins? And yes, we can see a horizontal translation. We can see that this AY just moves to the right, and then you take it again, move it to the right again, and continuously to create the strip pattern. Are there others that we can see? Possibly, yes. We see a reflection. So we can see a reflection across a vertical line to create the strip pattern. So, for example, I can take this A, bring it down the middle, whoops, and then this left side will flip over to create this right side. And then I could do it again at any other point. The A, I can strip down the middle, or draw a line down the middle, create the pattern again, and again, and again, and again. So it has a reflection across a vertical line that'll map onto itself. So again, a reflection that you can flip that will create the pattern again. We don't want to just flip it for the sake of flipping it. We want to flip it, translate it, transform it, whatever, to create the pattern again. So that's the goal of identifying, is can we identify things that'll create the pattern again all the way throughout the strip pattern. Okay, so for you try number 2, I want y'all to try to identify all the transformations in this strip pattern. Okay, and I got a list of them right here for y'all to check. So if you're on ClassKick, you can click on these images. I've provided y'all 2. This first one right here is just one of the triangles. If you click on it, this little line will pop up, and then you can click and rotate. You could also drag to determine what other types of transformations are going on. Same thing with this right here. You can click, rotate, and drag to identify these different transformations if they have any. And then if you can, mark each one with either a check or an X, depending on what you find. If you need help with, or if you need to know what the answers are, you can move the box right here and check to see which ones work and which ones don't. So go ahead, pause the video, try this on your own. Otherwise, I'm going to continue on and show y'all how to do this. Okay, horizontal translation. Can we move the pattern from left to right? First off, where does the pattern start? Where does it start to repeat itself? Right here. So can we take this original pattern and just move it left to right? Whoops. Yes, we can. It is a translation, horizontal translation. Just moves left to right. So the first one is good. Vertical translation. Can we move this up and down to repeat this following pattern? No. Yes, we're moving it, but it does not have a vertical component to it. Just a horizontal one. So, vertical translation, no. Reflection across a horizontal line. Can we draw a line down the middle and reflect it? Yes. If we draw a line specifically at these corners right here, we can take the top part and make it look like the bottom part. Okay, let me see where we're at. Well, this is the horizontal line, not that one. But yes, we can create the top image by reflecting it across the horizontal line to make the bottom image. So, reflection across horizontal, yes. Reflection across a vertical, also yes. We can create a vertical line right here in the middle, and then the left side can go across to look like the right side. So, this is good. Glide reflection. Can we move this image over and then reflect it to get the other image? And in this case, yes. Now, if we do this with just the singular, we can glide and then reflect across a vertical line right here. Create a vertical line, reflect it, and then glide back here and then reflect it to get to that point. So there is a glide reflection going on. Move these back to the position. So yes, glide reflection. 360-degree rotation. Can we rotate it to get to this image right here? No, because 360-degree rotation just puts it back in the original position. So like if you put a point right here, for example, and we try and rotate it 360 degrees, it'll just go back to the original. So 360 degrees does not make sense. 180 degrees, yes, because that means we're moving it halfway around a particular point. And then we could just do that indefinitely to create each image. So 180 degree makes sense. Again, the only two that doesn't, vertical and 360 degree. Everything else does make sense. Okay, so we have 1, 2, 3, 4, 5 of the 7 with checks. And then you could see these right here. Hopefully another attempt to get y'all to understand what we mean by all of these. But that's it for you. Try number 2. Dilation. Dilation is an increase or decrease in the size of the figure. You have a pre-image, which is the original image, and then you have the image that you're trying to create. Okay, now the pre-image has a certain size, has a certain shape, and in order to retain the same shape and the same proportion of size so that it doesn't look wonky when you change it, you're going to have to use something that's called a scale factor. That scale factor can be any number. It's not, as long as it's not negative and as long as it's bigger than 0. However, if it is between 0 and 1, then what the scale factor indicates is that this is going to be a reduction. Whatever image you're going to produce, you're reducing the size of the image if the scale factor is a number between 0 and 1. If the scale factor is more than 1, then we can deduce that the image is going to be an enlargement. So again, between 0 and 1, a reduction, more than 1, an enlargement. However, how do we calculate the scale factor? Well, there's some measurements that you're going to have to take. First off, you need to know what the measurement of the pre-image is, whatever side, doesn't matter. And then using that same side, you need to figure out what the measurement is of the image, what you're turning it to. Again, the measurement of the original and the measurement of the new image, what you're changing it into. You're then going to divide those measurements with each other, the image divided by the pre-image, and you will get a scale factor. That scale factor can be represented as a fraction, as a decimal, whatever. Could be as a percent as well. I don't know if you normally see that, but could be represented by all those things. Let's look at an example. I'm going to cover this up and then reveal it as we go. So let's say I want to change this L-shaped block into a new image. One of the sides of the pre-image, which again is the original image, the original figure, is 8 centimeters. And I want to change that measurement to where it is now 6 centimeters. I want to make sure that the proportions to the new image all stay the same. So I have to be consistent with how I downsize it. How do we do that? We do that by using something called a scale factor. To find out the scale factor, we need to take the image value of that side we're looking at and divide it by the pre-image value of the same side that we're looking at. And then we'll get a number. So in this example, the image that we're changing it to has a side of 6 centimeters. The pre-image, what it originally was 8 centimeters. So according to the formula, image divided by pre-image, this is 6 divided by 8. When you plug that into the calculator, 6 divided by 8, we have a scale factor in decimal form of 0.75. Let's say we want this in a reduced fraction form. What you can do with the TI-84 is hit math, enter, and you will get a reduced fraction of 3/4 for the scale factor. Either one, it doesn't matter, just whatever the problem calls for. But ultimately, the scale factor is 0.75. Now, let's say we didn't know what the image was, or the pre-image, and we were just given the 0.75. Well, because the 0.75 is between 0 and 1, we know that this is a reduction. So this reduction, 0.75, is a reduction from pre-image to image. Just to show y'all on the Desmos, if y'all were curious, if you type in 0.75 and then you click this fraction bar over here on the left, it will reduce the fraction for you if it ever calls for it. And there it is, 3/4. That's it for this example. You try number 3. What is the scale factor of this image? We have on the left side a pre-image where the length of the arrow is 4 centimeters, and the image where the length of the arrow turns into 18 centimeters. Again, intuitively, it's if you have the pictures there, it's easy to understand which one this is going to be, a reduction or an enlargement. And also, you can find that out by just calculating the scale factor itself as well. So, either way, you're going to have to calculate the scale factor for your final answer. To do that, you need the image. You need the length of the image that we're trying to create it into, change it into, which is 18 centimeters. And then the pre-image, which is 4 centimeters. Follow the formula, get the simplified fraction, and then decimal answer, and determine whether this is a reduction or an enlargement. If you're on ClassKick, then you can move this box to check your answers, see if you're doing everything correctly. So go ahead and try this on your own. Otherwise, I'm going to continue on and show y'all how to do this. So intuitively, if you had the images there, from original to the new image, we can tell that this is going to be an enlargement. Okay. Now, we can also tell by just calculating the scale factor too. So we know that the image is going to be 18. We know the pre-image is 4. 18 divided by 4 will give me a decimal of 4.5. Let's say I want the fraction form, so I could press math, enter on the TI-84, and it is 9/2. And so my scale factor is bigger than 1, therefore it is an enlargement. That's it for you try number 3. Here's another example. Carla reduces a 24-inch by 36-inch photo to a 4-inch by 6-inch photo. Find the scale factor. So there's going to be a few ways we can do this. We need to first identify the image and the pre-image. What is the original and what are we changing it to? So, reduces a 24 by 36 inch photo to a 4-inch by 6-inch photo. So this is the original. And then this is the image. Now that we've identified the image and the pre-image, we can find the scale factor by using their corresponding side. So I'm going to use blue to highlight that. So 24 corresponds with 4. And then 36 corresponds with 6. We can do either 4/6 I'm sorry, not 6. 4 over 24. Or we can do 6 over 36. Okay? Because notice how I'm aligning that. 4 with 24. This is the image. This is the pre-image. The first number associates with the first number of either one. And then the second number associates with the second number of either one. Okay? So 4 over 24 or 6 over 36. When you type those into the calculator, you're going to get the same scale factor. So 4 divided by 24 is 0.167 if you round it. And then 6 divided by 36, same thing, 0.167 or 1/6 repeating. So the scale factor is 0.16 repeating. However, let's say we want the fraction form, because saying 0.16 repeating is not exactly the best. So change this into a fraction. Math, enter, enter using the TI-84. And we have a reduced fraction of 1 over 6. That is the scale factor. We're basically reducing the original image by 1/6 of itself. And that is your final answer for this example. There are two ways. Either using the 4 and the 24 or the 6 and the 36. As long as you're using the formula correctly and associating the numbers correctly, you should get the right answer. Okay, you try number 4. A travel guide has dimensions 8 by 10 inches. What scale factor should be used to make an enlargement version that has dimensions 12 by 15? So, again, you have the scale factor formulas. Formula. You need to identify which one is the pre-image and which one is the image. Again, pre-image is original. Image is what you're changing it to after the dilation. So, fill out the formula, get a fraction and a decimal answer, and that's it. Check your work by moving the box right here. Try this on your own, see if you can do this. Otherwise, I'm going to continue on and show y'all how to do this. So a travel guide has the dimensions 8 by 10 inches. This is the original. I'm going to say OR for original. What scale factor should be used to make an enlargement version that has dimensions 12 by 15 inches? So this 12 by 15 is the image. Okay, so we have 8 by 10, and then we have 12 by 15. Either we use 8 and 12 or 15 and 10. But just remember which one you use first. You use the image first, and then the pre-image. So the image, let's say for 15 and 10, you'll use 15 divided by 10, which when you type it into the calculator, will give you 1.5 as a decimal. Or, if you turn it into a fraction, 3 over 2. If you use 12 over 8, it's the exact same thing. So 12 divided by 8. Again, the image over the pre-image. And then change it by pressing math, enter, enter. 3 over 2. You'll get the exact same answers. That's it for you try number 4. Okay, scale factor, but in terms of area now. Scale factor in terms of area. Notice how the formula is generally the same. However, the scale factor is now being squared. The scale factor is now being squared. So scale factor in this example of a blueprint of the front door of the actual front door is 0.04. The area of the actual front door is 36 feet squared. What is the area of the front door on the blueprint? So here's the formula. Scale factor, which is 2. Well, being squared, sorry. Scale factor, which is being squared, is equal to the area on the blueprint, which is the image. And then the area of the actual door is the pre-image, the original. We want to know what it'll be on the blueprint. So the blueprint is our goal. That is the image we're trying to get. The original is 36 feet squared. Okay, 36 feet squared. We know the scale factor is 0.04. So we're going to type in, or we're going to plug in what we have so far. 0.04 squared is equal to the area on the blueprint divided by 36. Well, we need to get the area on the blueprint, the unknown variable, by itself in order to solve. So we're going to do something called cross multiply. We're going to cross multiply the 36 from the bottom to whatever's on the top on the other side of the equal sign. So we're going to get the following. You can do these individually or put them all together. So you could just type in 0.04 squared and then multiply by 36. Or you can type it all together. 0.04 squared times 36, and you'll get the same answer. 0.0576 square feet is what's going to be on the blueprint. So we did a decrease, a reduction. We reduced the actual front door area to fit it on a blueprint, which is a much smaller version of it. And we did so by cross multiplying the information that was given to us. Okay, but again, you have to be careful with what information is actually given. You're not always going to cross multiply. It just so happens that we did this in this example. Okay, you try number 5. Scale factor of the blueprint of a garage door to the actual garage door is 0.05. The area of the actual garage door is 220 feet squared. What is the area of the garage door on the blueprint? So you have scale factor being squared because this is area now. You have the area of the image and then the area of the pre-image. You're going to cross multiply those values and then get your final answer. So remember, the area of the pre-image is the original value, the original garage door. And then from there, you're going to use the scale factor to cross multiply and get your final answer. Okay, so go ahead, pause this video, try this on your own. If you have ClassKick open, you can check out the answers behind this box right here. So if you would like to, go ahead and do that on your own. Otherwise, I'm going to continue on, show y'all how to do this. Okay, so what are we given? We're given the scale factor is 0.05. We know the area of the actual garage door is 220. So this is the pre-image, which I'll call pi, Pi. We want to know the area of the garage door on the blueprint. So we're decreasing its size from the actual size of the garage door to a smaller version of it on the blueprint. 0.05. 0.05 is that scale factor. Now we know the area of the actual door, garage door, is 220 feet squared. So now cross multiply. 220 times parentheses 0.05 squared. And we have 0.55. So that means on the blueprint, the area of the door, the garage door on the blueprint is 0.55 feet squared. And that's it. That's it for you try number 5. Okay, last problem. Scale factor for volume now. So exact same stuff, except now the scale factor is being cubed because we're dealing with volume. So in this example, scale factor of a large milk container to a small container is 0.08. The large milk container can carry 12,000 centimeters cubed of milk. How much milk can the small container carry? So what do we have here? We have the scale factor, which is 0.08, and then we have that the original container can carry 12,000 centimeters cubed of milk. So we fill out that part of the formula. Scale factor gets filled in with 0.08. Volume of large container is the pre-image, the original container, which is 12,000 centimeters cubed. And then we could also tell which one's the pre-image to the image. It says the scale factor of a large milk container to a small one. So the large is the original. And then the small is the image. Or I shouldn't say original, I should say pre-image. But anyways, that's it. Then fill that out. We get the following. 12,000 is at the bottom of the fraction. Then we have parentheses 0.08 cubed that we need to cross multiply. So you take out your calculator. 0.08 close parentheses. And to get the cube on the TI-84, you use this little arrow right here to get 3. If you're using Desmos, you're just going to type in 0.08 and then use the shift 6 to get the exponent, and then type in 3 and then arrow to the right. I don't want a fraction, so I'll just leave it like that. And then you'll multiply it with 12,000. Which is 6.144. I believe that'll be the same thing over here. If I multiply this by 12,000, 6.144. So 6.144 centimeters cubed is the volume of the small container. That's that for this example. Now on to you try number 6. The scale factor of a swimming pool to a small swimming pool is 0.12. The large swimming pool can hold 15,000 meters cubed of water. How much water can the small swimming pool hold? You have the formula with scale factor being cubed. Remember, the pre-image is the original. The image is what you're going after, what you're changing the original to. You're going to have to cross multiply some values to get the volume of the image, and then just type your answer right here at the bottom. Move the box to see if you did this correctly, if you're on ClassKick. So go ahead and pause the video, try this out on your own. Otherwise, I'm going to show you how to do this problem. So scale factor of a swimming pool. So a swimming pool to a small swimming pool. We can tell that the swimming pool is the pre-image and the small swimming pool is the image. We know the scale factor is 0.12. We know the large swimming pool can hold 15,000 meters cubed. Well, that's the large swimming pool is the pre-image. So that's going to go at the bottom right here. Now we just need to cross multiply to get our answer for the small swimming pool. 0.12 cubed times 15,000, which is 25.92. And again, if you want to do this on Desmos, you just type in parentheses 0.12, close it. You can hold shift, press the 6 to get that up arrow exponent. Type in 3, arrow to the right to get the cursor back on level. And then multiply by 15,000. And then you'll get the exact same answer, 25.92. So 25.92 meters cubed is how much water the smaller swimming pool will hold. And that's it for you try number 6. Okay, that's it for this lesson. If y'all have any questions, let me know. Send me an email, send me a message, whichever. If y'all need any help with me going through any of this stuff, then just let me know. Otherwise, just rewind the videos, rewatch this stuff over and over again. Math is all about practice. Okay? So, again, if y'all need me, let me know. Y'all have a good one. Take it easy, everybody.